You have written some JavaScript? Excellent. But how do you convince a web page to actually run it? Do you whisper it into the browser? Do you hide it somewhere inside the HTML? Do you perform a complicated programming ritual? Thankfully, it is much easier than that. When you open a website, your browser receives several files. HTML provides the content and structure, CSS controls the appearance, and JavaScript provides instructions and behavior. The browser begins by reading the HTML file from top to bottom. As it reads, it identifies elements such as headings, paragraphs, images, and buttons. It uses that information to create an internal representation of the page. This representation is called the Document Object Model, or more commonly, the DOM. You can imagine the DOM as a map of everything currently inside the page. JavaScript can use that map to find elements, change them, remove them, and create entirely new ones. But before JavaScript can do any of that, the browser needs to receive the code. There are several ways to give it JavaScript. The quickest way to experiment is through the browser console. Open the browser's developer tools, select the console tab. Then type console.log hello JavaScript. Press enter. The message should appear immediately. Congratulations, you just gave your browser a JavaScript instruction. The console is useful for testing ideas and investigating problems. But code entered there is temporary. Refresh the page and your experiment is gone. To make JavaScript part of a website, we use the HTML script element. One option is to place JavaScript directly inside it. For example, script console.log, the page is alive. This is called an inline script. It works well for tiny demonstrations, but large amounts of JavaScript mixed into an HTML file can quickly become difficult to read. It is a little like storing your socks, plates, books, and houseplants in the same cupboard. Technically possible, not especially organized. A more common approach is to place the JavaScript in a separate file. You might call it script.js. Inside that file, you write normal JavaScript. Then you connect it to the HTML like this. The src attribute tells the browser where to find the JavaScript file. When the browser reaches this element, it loads the file and executes its instructions. But the position of the script matters. Remember, the browser reads HTML from top to bottom. Imagine that your JavaScript tries to find a button, but the button appears later in the HTML. If the script runs too early, the browser may not have created that button yet. JavaScript searches for it, it finds nothing. And now your code is trying to have a conversation with a button that does not exist. A traditional solution is to place the script near the end of the HTML body. By that point, most of the page has already been read. But there is also a useful attribute called defer. It looks like this: script, source script.js, defer. With defer, the browser can download the JavaScript file while it continues reading the HTML. It waits until the HTML has been parsed before running the script. This means your JavaScript can access the elements on the page without unnecessarily stopping the browser from reading the document. Modern JavaScript also supports modules. A module script looks like this: script, type module, source script.js. Modules allow you to divide your code into separate files and share features between them using import and export. Module scripts are deferred automatically. You don't need to add the defer attribute to them. Once the JavaScript begins running, the browser's JavaScript engine takes over. The engine reads the code, it interprets or compiles it into instructions the computer can execute, then those instructions run in order. For example, JavaScript might store a value, then find a button, then attach an event listener to it. The event listener waits, nothing happens until the user clicks the button. When the click happens, the browser reports the event, JavaScript responds by running the associated function. That function might open a menu, change some text, start an animation, or accidentally turn the entire page bright pink. JavaScript also communicates with special features provided by the browser. These are called web APIs. They allow JavaScript to interact with the page, respond to timers, make network requests, store data, play media, and use other browser capabilities. These features are not all part of the JavaScript language itself. The browser provides them to the JavaScript code. So here is the complete journey. The browser loads the HTML, it builds the DOM, it discovers the script element, it loads the JavaScript engine executes the code, and the code can then interact with the page and respond to events. HTML creates the stage, CSS designs the scenery, JavaScript tells the actors what to do. And sometimes, when there is a bug, JavaScript forgets the script, knocks over the scenery, and leaves a mysterious red message in the console. Luckily, learning to understand those messages is part of becoming a developer.